Hello, welcome back to Precalculus. Today we'll be covering section 1.2, the domain and range of functions. The domain of a function is all the possible input values. If we think of our function like a machine again, it becomes pretty clear. This box is all of the stuff that we can put into the function. We can't put anything else in the function. It has to come from this box. Everything that comes out of the function will go into this box, our range box. Think of it like a conveyor belt at a factory. You can put anything on the conveyor belt, but it probably won't work unless you put the right things on it. If you put something on the conveyor belt that does not belong, aka something that is not in this box, it's not going to work. Let's take a look at this example. You have f of x equals 1 over x minus 3. I know it seems a little unorthodox, but when we think of domain, we normally don't think of what you can plug in. You normally try to find out what you can't. So let's look at this and see anything that might make a problem. Our normal troublemakers are fractions and square roots. So we have a fraction, and the problem with fractions is denominators. The thing you should know about denominators is your denominator can never be 0. Let's try to find what x value would make this denominator 0. If we set this equal to 0 and add 3 to both sides, x would equal 3. So you know that you cannot plug 3 into this. Let's see what happens if you try. You would have 1 over 3 minus 3, which is 1 over 0. And this is undefined. You cannot have that. Therefore, your domain would be all x values such that x does not equal 3. This notation is called set builder notation. We'll talk about the notation in a bit for writing domain and range. Now that we know that the domain is the things that come from this box into the function, we can figure out what the range is by looking at what comes out of this function. Sometimes the range is harder to find, but it can help to imagine the graph or think about what y values the function can actually make. Here's another example. G of x equals x plus 2. First, let's find the domain. We know that our normal troublemakers are denominators and square roots. We know that denominators cannot be 0, and the stuff inside a square root has to be greater than or equal to 0. You can take the square root of 0, you can take the square root of stuff bigger than 0, but you cannot take the square root of a negative number. To find the domain, let's write an inequality where we set everything inside the radical greater than or equal to 0 and solve. We will have x plus 2 is greater than or equal to 0. X must be greater than or equal to negative 2. This is our domain. This notation is called inequality notation. Now that we know our domain, let's try to think about this intuitively on a number line. If we have a number line, we know that the farthest left point will be negative 2, because all of our x values must be greater than or equal to negative 2. So our graph only exists in this region over here. Nothing happens in this region. Let's see what happens as x gets greater and greater. Let's try 2 and 7. At x equals 2, you're going to have the square root of 2 plus 2, which is equal to the square root of 4 or 2. So we know here y equals 2. Let's check out 7. At 7, we'll have the square root of 7 plus 2, or the square root of 9, which equals 3. So here, y equals 3. What about at negative 2? At negative 2, we have the square root of negative 2 plus 2, which is the square root of 0, or 0. So here, y equals 0. There's a very clear trend here. As you go further and further to the right, y gets greater and greater. And you know there's nothing to the left of this point, so this must be the lowest y value right here. So now we know that y is greater than or equal to 0. This is our range. Now that you know what domain and range are and what they mean, let's talk about how to write them. There's 3 main methods for writing domain and range. There's interval notation, there is set builder notation, and there is inequality notation. Each 3 has its perks. It doesn't really matter which one you use, it's preference, but sometimes one is easier than another. Here we're asked to write x values between negative 3 and 5, not including 5. Let's try that first with interval notation. In interval notation, you are using brackets and parentheses. You use a parenthesis to indicate that a value is not included. You use a bracket to indicate that the value is included. So let's try this one. You always start with the smaller number of the two. That is a given. You never write the bigger number first. We know that 5 is not included and -3 is included, so we're going to start with a bracket. Then we have -3, comma, 5. Remember, 5 is not included, so you use parenthesis, not a bracket. This is how you could express domain in interval notation. Next, let's try set builder notation. For set builder notation, you start with a curly bracket. Then you write your variable in question. Sometimes you'll be asked to indicate what set it's from. You could say it is an element of the real numbers. Most of the time that's implied, so you don't need to put it there. Then you write this line that says such that. So you're saying x such that this condition is met. Then another curly bracket. Our condition in this case is that x is between -3 and 5. So we'll say -3 is less than or equal to, because it has to be -3 as well, it's included, x, which is less than 5. It's not less than or equal to 5 because it doesn't include 5. This is our condition. Now we close the curly bracket. And that is our set builder notation for domain and range. Now for our third method, inequality notation. This one is very similar to set builder notation, except you lose the curly bracket and you lose the x such that you just write -3 is less than or equal to x is less than 5. That's your inequality notation. Set builder notation might seem a little redundant now, but I promise there is cases where it's useful and you should remember it. Before we move on, I have a little mini practice section here. You can pause and try it yourself, or you can follow along with me. Here, we're asked to write x is greater than 1, so we know x is greater than 1, but it's also less than 5, so x would be less than 5. How to write that in interval notation? Well, remember, you always start with the smallest number, and you know that it's not included because it's not greater than or equal to 1, it's just greater than 1. So we have a parenthesis, then a 1, then a comma, and then our biggest value, our upper bound. And remember, it's still not included because there's no equal sign here. So you write 5, and then a parenthesis. I know it kind of looks like an ordered pair or a point, but it's not. This is just interval notation. It does get a little confusing at times, so make sure to label your papers correctly. Next, we're asked to write x is less than or equal to -2 in interval notation. So we know x is less than or equal to -2. Let's think about that on a number line. On a number line, we would have -2 somewhere right here, and we're talking about all values to the left of -2, with -2 included. Because x is less than -2, we're going to the left. If this goes to the left forever and ever, this will go to -infinity. And remember how we always start with the smallest value? If it goes all the way to -infinity, we're going to start at -infinity. Then we have a comma, then we have our -2. But -2 is included because it's greater than or equal to -2. So we use a bracket here instead. One little note, no matter what, you never include an infinity. If you have -infinity or positive infinity, you always use parentheses, never use a bracket. Sometimes a function will have more than one restriction. As you can see, we not only have a square root, but we also have a denominator that could equal 0. Let's focus on the numerator first. We know that the stuff inside has to be greater than or equal to 0, so let's set it equal to that. Then we add 1 to both sides. We get x is greater than or equal to 1. That's the first step of our domain. That's not the whole domain, but that is the first step towards it. Now let's look at the bottom. X minus 2, we know cannot equal 0. So if we add 2 to both sides, x cannot equal 2. That's the second part of our domain. We have to incorporate both of them together. Let's think about this on a number line. We know that at 2, there's going to be a hole here, because x cannot be equal to 2. We know that at 1, we're going to have a closed circle, because it can equal 1, and we want all the values greater than 1. So we're going to go to the right, there's still a hole there, and we're going to keep going forever and ever and ever. For this example, I'm going to use interval notation. Now we know that our domain starts at 1, that is our smallest value, and it's included. Then we go up to 2, and we don't include it. I know it seems odd that we stop at 2, but this is an important step I must show you. When there's a hole like this, what you're going to do is called a union. You're going to put this U symbol here, and now you want to show all the stuff that's on this side of the hole. We already showed the stuff to the left of the hole. Now we need to show the stuff to the right. So we know it starts at 2, but 2 is not included. And it goes all the way to the right forever, to infinity, with a parenthesis. Remember, no brackets for infinity. And this would be our domain. This little U symbol says that not only is the domain the stuff in here, but it's also the stuff in here. For this example, you may see that we don't have our usual troublemakers. We only have an x squared. And yes, in this case, since both of our usual troublemakers are gone, our domain, I'll write a D, is going to be from negative infinity to infinity, all real numbers. As for our range, let's talk about that a little more. Let's try to think about what values could possibly come from this. Let's use a table to represent it. If I have x up here and f of x down here, and let's start in the middle and say we plug in 0. We get 0 squared, which is 0, minus 4, which equals negative 4. Okay, now let's try going to the right. Let's plug in 1. You plug in 1, you get 1 squared, which is 1, minus 4, which equals negative 3. Okay, let's see what happens when we go one more to the right. If you plug in 2, we get 2 squared, which is 4, minus 4, which equals 0. As you can see, there's a pretty clear trend here. As our x increases, our y also increases. Let's try going to the left now. If we go to negative 1, what happens? Negative 1 squared is 1, minus 4 is negative 3. And I think you can already see where this is going. No matter what negative number you plug in, you're going to get the same as it was on the other side. If I plug in negative 1, I'm going to get negative 3, like I got for positive 1. If I plug in negative 2, I'm going to get 0, like I got for positive 2. This should be intuitive from the shape of a parabola, which looks like this. As you can see, we plug in a value on the right side of the x-axis. We're going to get the same y value as if we plugged it in on the left side of the x-axis. This means that our lowest y value is right here at negative 4. That is the absolute lowest we go. Since we actually got that out of the function, it's included. So we'll have a bracket here and a negative 4. And this function goes on and on up until infinity. So we'll go up to positive infinity. That will be our range. In summary, your domain is all your possible input values, or your x values, and your range is all possible output values, or the y values. You should watch out for denominators, they cannot equal 0, and square roots, the stuff inside has to be greater than or equal to 0. Before I go, I have 2 practice problems for you to try. Here are your 2 practice problems. You can pause here and try them, or I'll give you the answer and work in 3, 2, 1. Here are your answers, but I briefly want to touch on question 2 for a moment. You can see here I started out at x equals 5 to find my range. Why did I start at 5? Well, let's think about this intuitively. 1, if I put in 5 here, I very clearly get 0 under the radical. And that gives us a pretty number. It gives us 0 back. If I plugged in 2 per se, I would get a square root of 3, which isn't a very pretty number. Another reason is, if you look at our domain, the biggest x value you can plug in is 5. You can't plug in anything bigger than that. And you can see, as our x values get lower, our f of x increases. So you could probably infer that if you could go higher than 5, that it would decrease the other way. However, it stops at 5. You can't go that way anymore. So this is the lowest value you're going to get. Thank you for watching. My tutoring email will be in the description, and I'll see you again for Precalculus 1.3.